Okay, you should be able to see my screen now, right? Worksheet 11. Question 1, no problem. Okay, so now what do? I will be looking at all your responses. Okay, and then I'll see those questions that you are struggling with, having problems, then I'll be focusing more on them. For those questions that majority of you or all of you got correct, I wouldn't spend so much time. Okay, so it's not going to be like previous lessons where I am going to explain so many things for all the questions. Okay, Anaki, you have not started lesson, is it? This term. All right, thank you, Anaki.
Well,
okay. Okay, so for this particular one is very straightforward. We know that convection actually takes place in liquid and gas. Okay, none of you got this wrong. All right, so this one I wouldn't be spending time to explain. Convection can only take place in liquid and gases because the particles can move. Now, question 2. This one also no problem. You're supposed to identify how heat from a campfire can be transferred, right? So if you are going to look at this very carefully, right? Okay, look at the diagram. None of you got this wrong also. I think it's pretty clear cut, right? So when this part of the bar, let's say it's a metal bar, is heated, you know that the heat can actually be moved up the bar or moved along the bar by conduction. This one, no problem, right? Okay, I know Sharon will be struggling with understanding this, because Sharon has not done this topic yet, correct? And you have not watched the video as well. So Sharon, you have to try to focus on how we go through the lesson rather than trying to understand what we are going through now. Because I don't want to reteach the whole topic for you lah. Okay, because the rest of them already learned this. Okay, so you see how we actually go through questions like this and see whether you're comfortable with this. All right, okay. Now, so we know that this is actually conduction, okay, for Z. Because you're talking about the heat that is moving through the bar. Look at the arrow pointing, okay, the heat that is actually being transferred from this end of the bar to the other end. Okay, for this one, for Y, okay, from the side, if somebody can feel the heat from the campfire when he or she is a distance away, this has got to be radiation. All right, and then X is convection. The air above the flame, okay, or the fire gets heated, expands, becomes less dense, and rises. So this is convection. I think all of you, okay, should know this. All right. So question 2, no problem. Okay, in fact, you can find diagrams like this easily. Take a screenshot if you want to. All right, take a screenshot if you want to. Okay, so heat transfer happens in 3 ways: conduction, convection, radiation. Yeah. Now, during a fire in an enclosed area, firemen, okay, need to do something. And this is what firemen always will do. Question 3 is actually not an issue left for all of you. Okay, but then just to quickly cover this, during a fire, you are not going to be walking straight up. Okay, as much as possible, you keep nearer to the ground. Okay, even you can bend down, it's good for you. Why? Because you know the heat rises all the time, right? During fire, okay, all the hot air will be rising, cool air will come down. So if you want to prevent yourself being too hot, getting too hot, or becoming too hot, right? You should keep near the ground, okay? Because when the hot air moves, the smoke from the fire will also be brought upwards. So it also prevents you from choking. So if you were to take note, okay, you will see people running in the fire, they will crouch a bit lower. Why is that so? Because they want to prevent heat from going to them, okay? And they want to prevent the smoke from also choking them, going to their eyes. Now, question 4. Okay, it's actually not tough. I know that you don't know what is thermocouple. I am not familiar with thermocouple as well, okay, because I hardly use it in my life. Okay, but then thermocouple is a device that is used to detect heat, okay, or you say heat radiation. Now, this paragraph is just explaining to you, all right, how it works. So this thermocouple is actually connected to a galvanometer. Galvanometer register current. So what happens here is if there is a lot of heat received by the thermocouple, there will be a greater deflection in the galvanometer. Greater deflection means it will read a higher current, okay? Greater deflection means it's going to read a higher current. If it has only a very small deflection, right, the reading is small. The greater the deflection, so you're going to see how the pin moves. Let's say it starts from 0, okay, then it moves a little bit. That's a little deflection, right? If there is a lot of heat, it's going to deflect a lot. Okay, so this is how the deflection works. Yeah, it's not a digital reading. Okay, this particular one is actually telling you the values by the movement of the pin, just like our clock, not the digital ones. Okay, now if you look at this experiment now, they are using these container, right? They call it a cubic metal container, but the surfaces of the container, okay, are painted differently. One side is matte black. Matte black is not shiny black. Okay, you see now, right? Some cars, right? Sports car, instead of shiny black, nowadays they like to put that kind of matte black because it's going to look very cool. Yeah, so matte color, not shiny at all. The surface, okay, matte surfaces are not that smooth, a little bit rough, little bit. White color over here, okay, white. It didn't say shiny white. It didn't say matte, but we know that if it's not stated, okay, we will just take it that it's not shiny. Silver. Silver is shiny, reflective. Glossy black. Okay, no doubt it's black, but it's still a little bit reflective. So if you're going to compare this, okay, if you're going to compare this, of course, matte black, right, will give out most heat. When it gives out most heat, right, it will actually cause a greater deflection in the galvanometer. So the reading will be the biggest. You understand what I mean? Okay, Sneha, you got this correct? So Sneha, you understood that, the deflection actually tells you whether it's a bigger reading or smaller reading, right? Yeah. So when it's a smaller deflection, the reading is actually a lot smaller. So when the deflection is the most, that means the reading on the galvanometer shows the highest current. Now, in this case, okay, silver being reflective, it will actually give out the least heat. All right. The notes that I've given you last week, if you look at the notes I gave you last week, you will actually see this, right? Yeah, of course, this doesn't tell you much, isn't it? Because this just tells you good and bad. But then the rougher it is, the more dull black it is, it will be, okay, the best absorber and the best radiator. Yeah. So maybe let's see how I can improve on this. Dull black is the best, okay? And then if you have glossy or shiny black, I think glossy sounds better. Okay, so this one I don't indicate, but you know that dull black will be the best. Okay, and then white, shiny compared to silver. Shouldn't put best radiator. It's a best reflector. So worst. Y'all don't take screenshot first. Let me just finish this up for you. Silver is the best reflector of heat. I would like you to write this down or to have this notes. Okay, silver is the best reflector of heat. So do you remember an example in daily life? How many of your parents drive cars? They drive, right? So do you see that they actually put this silver kind of thing in front at the, no, didn't. You all don't do that. Okay, in the past, I do that. Nowadays, I don't. I got lazy. But if you go and take a look, right, at the other car, sometimes you see that they put one piece of thing, after they park, they actually put one piece of this silvery foldable cover, yeah, just to block light. They say block light. Actually, it's silver, its silver surface is pointing outwards, right? Because it's trying to reflect the heat from the sun. I think they call it the car sunshade, if I'm not wrong. Haresh, you think this is the right term? The sunshade, right? Should be called the sunshade. You don't know. Okay, yeah. So take a look at the silver surface of that sunshade. If I can get a picture, I can show you. I just suddenly thought about it. Yeah. Okay, so take the notes here now. If I look at question 5 is not a problem. Let's see. I think, Sneha, you didn't read properly, probably. Yeah, and then you chose it too fast. Okay. Anything that is left, let's say, on the table, be it the cake that is just baked, be it the food that is just cooked, be it hot drink, be it the boiling water, do you know that all of them will lose heat by all three ways? It's just like the campfire. It's just like the campfire. Always try to remember. Because when you put your hand near the cake, you don't have to touch it. Okay, you just put by the side. Don't put on top of it. On top of it could be convection of the air. But if you put by the side, near it, you can feel the heat. That is by radiation. Clear? Okay, convection will be always the upwards, because always remember about convection current. Hot air rises, hot water rises, hot fluid rises. Okay, that is how heat moves in convection. Radiation totally don't need any medium. You don't need solid, you don't need liquid, you don't need gas. Yeah, so radiation can take place without any medium. That's why when your hand is near the hot food, you can feel the heat. Okay? And then by conduction, it's when the cake is placed on a plate, okay, or placed on any holder, that is where the conduction can take place. Heat is lost from the cake to the holder, all right, and then to the environment. Any question here? Anaki, are you okay, Anaki?
Yeah.
Okay, question 6. Yeah, we have people making the error here. Which of the following statements about radiation is incorrect? Now we're talking about incorrect. All right, black surfaces are good emitters of radiation. Okay, objects with higher temperature emit radiation at a lower rate. So read all these carefully first. Objects with larger surface area absorb radiation at a higher rate. Okay, then radiation travel through vacuum. Which of these